ever typed a website like google.com into your web browser and wondered how your computer actually knows where to go? It's not magic, it's something called DNS. DNS, or domain name system, is what makes the internet human-friendly. Instead of having to remember an IP address like 142.250.190.78, you just type in a name, and DNS takes care of the rest. In this video, we'll break down what DNS is, how it works, and why it's critical for both functionality and cybersecurity. And as a quick callback to our previous video on ports and protocols, DNS runs on port 53, both using TCP and UDP. So if you watch that one, this will help connect the dots. With that being said, let's get into it. DNS stands for Domain Name System, and its main job is translating human-readable domain names like tacobell.com into an IP address that computers use to communicate. Think of it like the internet's phone book, or maybe even a contacts list on your phone. If I wanted to call my friend Noah, I would find his name in my contacts list, swipe to give him a call. My phone won't call Noah specifically. It calls his actual phone number. And DNS works the same way. It takes the name that you type and finds the IP address associated with it. Without DNS, we'd have to memorize IP addresses for every website we visit, and that's simply just not practical. Let's walk through the process that happens with DNS when you try to visit a website. First, you type in a domain name like tacobell.com into your web browser. Your computer then checks its local DNS cache to see if it already knows the IP address, and if it doesn't, it sends a DNS query to a recursive DNS server, usually provided by your internet service provider or a public DNS service like Google using 8.8.8.8 or Cloudflare using 1.1.1.1. The recursive server then contacts one or more authoritative DNS servers to find the actual IP address for the domain. Once it gets the answer, it sends it back to your computer. Your web browser then uses the IP address to make a connection to the server, often using port 80 for HTTP or 443 for HTTPS. All of this happens in milliseconds without you ever noticing, unless something goes wrong. Now, DNS doesn't just return IP addresses, it uses different types of records depending on the request. Here are some of the most common. First, we have an A record, and this maps a domain name like tacobell.com to an IPv4 address. Next, we have quadruple A records, and these are basically the same as an A record, but for IPv6 instead of IPv4. Next, we have CNAME records, and this points one domain to another domain name, very much like an alias. Next, we have MX records, and this is used for mail exchange. It tells email systems where to deliver messages. Lastly, we have TXT records, and these can store any text, and are often used for verification or SPF and DKIM settings in email security, but we'll cover that in a later video. Now, these records are all stored on authoritative DNS servers, which are like the official source of truth for a domain. Now, DNS isn't just about convenience and functionality. It plays a huge role in security. Attackers often exploit DNS for malicious purposes, including phishing using domains that look like legitimate ones to trick users. There's also DNS hijacking, where DNS queries are redirected to malicious servers, and DNS tunneling using DNS to sneak data in or out of a network, often part of a command and control channel for malware. And that's why monitoring DNS traffic can reveal early signs of compromise. And many security tools now include DNS filtering or DNS layer protection to help block malicious sites before users ever reach them. So that's DNS, the system that helps your devices find the right destination across the internet. It takes something complicated like an IP address and makes it simple and user-friendly, but it's also a critical part of your organization's security posture. Knowing how DNS works, what type of records exist, and how attackers try to abuse them gives you a serious edge when it comes to protecting your network. If you found this video helpful, please consider subscribing to the channel or check out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.